There's a mystique in the world of audio around vacuum devices, and whether you call them valves or tubes, there are many hi-fi components using them to temp the audiophile. The barrier to entry for tube hi-fi is generally quite high, but if you just want to experiment, there's a very cheap tube preamp kit you'll find from the usual online retailers for somewhere under $10. It's usually advertised as a preamplifier and headphone amplifier, but the reality is that it's pretty useless for either. Can these $10 boards be made to do something more useful? Stick around and I'll introduce a couple of ways to turn them into a very cheap headphone amplifier. The circuit diagram of these boards is pretty simple, with the two small pentodes wired as triodes in a very conventional single-ended amplifier circuit. The part in question is the 6J1. It's an RF tube of the kind you might have found in a 1960s VHF radio. I can only speculate, but I'm guessing somewhere in China there's a huge military surplus stockpile of these things. Most of the board is taken up by a power supply circuit that takes a 12-volt AC input and feeds it through positive and negative voltage multipliers to achieve a split supply with a final HT voltage of around 70 volts. As it stands then, the circuit is a fairly conventional single-ended preamplifier. It will clip if you turn the volume up too high, and it doesn't have any particular response curve applied to it. As a headphone amplifier, it's a non-starter because its output is at far too high an impedance to drive a normal pair of headphones. If I want to make a headphone amplifier from this board, I have to find a way for it to drive a low impedance output, and I have to hope it has enough gain to drive the phones to an acceptable volume. I'm going to try two ways. First, a simple transformer output in this video, and then a MOSFET source follower in a future installment. The principle of the transformer is simple enough. I find one with a large number of turns on its primary side and a small number on its secondary, which in turn presents a high impedance to the amplifier and a low one to the output. These are the parts that make those commercial tube amplifiers so expensive, but fortunately here there's a much cheaper alternative. I'm not sure why this component is still being manufactured, but early in the days of transistor amplifiers, it was common to find a transformer circuit being used as it had been in the tube days. Thus, there are small audio output transformers for transistor circuits that are very cheap indeed, and a pretty good fit for this application. I've simply removed the anode resistor from the preamp board and substituted it with the primary of my transformer, and the secondary is wired to a 3.5mm socket for my headphones. The transformers are mounted on a piece of perf board. The wiring is done with PCB pins and jumper wires. A 3D printed shelf keeps the perf board in place above the input sockets. With the anode resistor replaced by the transformer, it will drive a set of headphones, but the volume is a little low. This is fixed by adding a 22 microfarad capacitor as an AC bypass across the cathode resistor, which improves matters hugely. I now have a very listenable little stereo headphone amplifier, but it's still not perfect as it's too bright. In short, there's good mid and treble, but the bass isn't there enough. I'm happy with the results I've got for such a small outlay, but it can be improved. If you have an amplifier with an uneven frequency response, the solution is to apply some negative feedback. In a triode circuit like this one, that's done by a resistor and a capacitor from anode to grid, with the resistor being pretty large and the capacitor being quite small. The idea is that it reduces the gain to a flat level across the board, flattening out any frequency response humps. I tried this and experimented with component values, but it's not the silver bullet you might think it is. The feedback is being applied to the triode, while the undesirable response comes from the output transformer, which isn't part of the feedback loop. I can fix this by taking some feedback from the output of the transformer to the input of the amp, but then I enter a whole world of pain as I destroy the amplifier's phase response. When I was a student, I was very proud of my homemade stereo valve amp, but the truth is it has exactly this problem, because my feedback went through the transformer. Frequency response was great, but it sounded somehow woolly, lacking sibilance. I can add some kind of passive bass boost on the input to make it sound better, and I may indeed do that, but perhaps these cheap transformers aren't the way to go. I mentioned the other method of impedance transformation as putting a follower on the output. I'll be back in a future video to try that. Meanwhile, I can at least listen to my $15 tube headphone amplifier, and to be honest, it doesn't sound that bad. I don't have a sponsor for my videos, but as before, I'd like to take a moment to talk about something else I'm involved with. I'm a board member of a small non-profit called Trans Rescue. We exist to help trans people like me escape dangerous and dodgy places around the world. I'd like you to take a look at our website and see what we do, and if you can, help us to continue our work. Thanks very much, and thank you for watching this video.